All right, so now that we got the analyzer here again, just kind of our front view. Before we get into the inside, I'll show you the fast loop reservoir kind of on the outside of the analyzer. Again, main thing here is this float switch. The connection comes into this this connector here at the side of the box. And once that's in, and now since we don't have any flow, if we swap over to look at our screen real quick, we'll see that a no flow alarm here popped up on our screen. And again, if the analyzer was in the middle of taking an analysis, it would finish the one it was doing, and then obviously when it came back, time to start a new one, it would, not start and go into standby. For now, we'll disconnect it because we want to pretend that we have sample, and that alarm goes away. Again, in normal operation, you would have your tube to the analyzer connected here. And then this tube is what goes into our analyzer on the inside. Right here. So once that tubing comes in from our sample line, it will go into the number 1 port here on our selection block. And then the number 2 port would be connected to our calibration standard, which in this case goes right down below to our calibration standard here. Just get a real quick look of the components on the inside, kind of in person, before we go through like startup. Again, reagent pumps, iron will have 1, the hardness will have these 2, and won't have the third. Neither will have the third one. Our sample pump here. Again, this is our flow cell block. This is just a little finger screw that kind of holds the flow cell in place, make sure it doesn't turn or move too much. Just remember, if you have to take the flow cell out, to loosen that, and then you'll be able to slide the flow cell out. The pinch valve drain here. If you were to manually just push this in, you'd see our flow cell empty out of all of its sample and drain out the bottom. Same thing happens when that valve is electronically activated, just opens up and drains out anything that's in that valve. These are our tubings that go to our reagent pumps. This overflow tube here is tied into the outside, which is just a drain vent, which ties to our drain on the bottom of the analyzer that just goes out to waste. Here we have our LED, and again, just our mixing loop. And after we run a cal, I'll actually pull this off just so you can see the mixing pump and the LED and the detector board and what they look like if should we have to get access to them. So basically right now is what I'll do is I'll go through basically your startup procedures in terms of installing your reagents, priming the lines, and then we'll run a calibration. So again, this will be the same process if you're starting off from scratch, or if you're doing your monthly reagent replacements, or coming out of an extended shutdown period. As you can see on the bottom here, below the analyzer, we have our reagents. Again, with the hardness and the iron, different number of reagents, but also the bottles will look different. The iron reagent, the iron analyzer uses a smaller amount of reagent, so it's only a 1 liter bottle, and then the hardness bottles are 2 liter bottles, so they're smaller and they're a little round. But the idea is the same, in that when you get your bottle, you'll just open it up, and then with the analyzer comes a separate cap that has a hole and a grommet in it. Again, the caps will match the bottles that you guys have. So as far as installing the new bottle, again, your analyzer will alarm out at about 10%, and then at 4% it should kick into standby mode. And it's always a good idea to just discard everything that's left in the old bottle and just open the new bottle up fresh. You don't want to risk a contamination of dumping the last couple milliliters of whatever's in the old bottle into the new bottle. Just not worth that extra couple of readings you might get. So on the bottom of the analyzer, you have your reagent straws, which connect to the bottom of our reagent pumps. Again, simple as just putting that straw in to the bottle. Usually they're numbered, so for instance, this one says, you know, an R2 on it here. Probably can't see in the video, but you know, line up R2 with their second reagent, and then the second reagent pump, and so forth for all three reagents. Definitely worth noting that some of the reagents are you know, slightly hazardous or corrosive. You know, the STSs with them will explain that, but not a bad idea to wear gloves and just be mindful of where you're dumping and or spilling them. So once we got our reagent straws, again, I had already done the calibration standard earlier, but same thing with the calibration tube, which hooks into this second port on our selection block. Now if we'll come up to our screen, and we'll be able to see a little bit better on this one. What you can't really see is along the bottom here is a reagent percentage. And again, that's the percentage that counts down. Whenever we're doing a replacement, we'll want to tap on that percentage number, and it'll basically ask you this question: did you refill the bottle? If you didn't refill the bottle and you just hit it by accident, you just hit the X, and the number will stay the same. If you did replace the reagents, you'll want to hit yes, and it'll put that percentage back up to 100%. So on your iron, the only number that should move is your reagent 1. On your hardness, you know, 1 and 2 should both be changing. Again, important to note that that number isn't actually measuring what's in the bottle, just what the analyzer thinks it's used. So again, if there's a huge discrepancy, you know, worth looking at your reagent pumps as a troubleshooting item. Also, the reagents, in the case of the hardness where there's 2 reagents, should be used at about the same level. So if you're you know, going through all of your reagent 1's empty, but your reagent 2's still full, you know, that's an indication that one of the pumps isn't working correctly, or something else is wrong. The calibration standard will go at a different rate than the reagents, just based on calibration frequency and so forth. So that one doesn't have a percentage counter on it, and it's kind of up to you to do your visual checks and make sure that you don't run out of cal standard. Obviously, it's good practice if you replace it when you replace your reagents every month, unless for some reason you ran a lot of manual calibrations in that month, you will have plenty of reagent to run your auto cals. So once we've got our reagents installed, then we've updated the counter. We'll want to prime the lines. So we'll hit this display menu. And then this will bring up our screen that has, again, all these reference readings, sensor values. And we'll come over to our manual screen, which will see our drop-down menu of all the commands that we can run. So the first thing I'm going to do here is I'm just going to do a sample 2 for 15 seconds, which is just going to draw in calibration standard and just fill up our flow cell with a little bit of standard. And once I hit that, you can hear probably pumps starting to turn. Our sample pump's moving. We can see our sample getting drawn into our flow cell here, and should start to fill that up. And then once the 15 seconds is over, it'll stop, kind of be back into mode waiting for the next command. What you can also see here is that our sensor value kind of jumped up. So anytime the flow cell empties, our sensor value will drop down to about 4 or so. And then anytime there's sample or standard in the flow cell, generally the sensor value is going to be between about around 9 or so. Again, that number doesn't necessarily have to be exact, because every time it takes a reading, it's going to recheck that number for a new start point. But now we can go ahead and prime our reagent lines. So we'll go down our menu to find add reagent 1, and then we'll change our timing to 60 seconds. And then we'll hit on. So now we'll hear our reagent pump start to turn. If we get it real close, we're going to want to look and make sure that we can actually see the droplets of reagent coming from this tube into our flow cell. That'll be a good indication that we've primed our lines. There we go. So once we see that, we know that the line is primed. And again, 60 seconds is the time that'll flush it a little bit and should get you your reagent flowing nicely. So again, for our iron analyzer, we'd be basically done with our prime. We only have one reagent. But in this case, in order to run a calibration, I will have to do the same thing for number 2 and number 3. And again, same thing, we'll watch the flow cell, make sure our reagent is getting injected. And you can also see that right here we've got our sample getting circulated through the flow cell, so that's a good indication that our mixing pump is working correctly. Anytime you do an add sample or drain or add reagent command, the mixing pump also is going. There's also a command to dismiss, if you want to check. You can see now we've got our second reagent being added in to the flow cell. And once number 2 is done, we'll go back and do the same thing for number 3. So now once all of our reagents are added, I'm going to do a quick manual drain